Okay, so for today's lesson, we will be talking about rational exponents and radicals. So remember, an exponent is something like when we have x to the fourth. This is our exponent. And a radical is the same thing as a root. So a root looks something like this. We know if there's no number there, then we must be taking the square root, but we could have a 3 or a 4 there, and we'd be taking the fourth root. All right, so something to keep in mind is that when you have a fraction with two numbers in them, the top of the fraction is always your exponent, and the bottom of the fraction is always your root. All right? So top exponent, bottom root in a fraction. So exponent over root. Keep that in mind. So on our first set of examples, they say to write each expression in radical form. Remember, a radical is the same thing as a square root or a root of any number, right? So we need all of these to end up having a root in them. So my fraction here, I've got 11 to the 1/7 power. Remember, the top is my exponent and the bottom is my root. So when I make my root, so the bottom is my root, I must have a root of 7, and my 11 has an exponent of 1. Because that's what we have in the top. Now remember, it's not necessary that you write this 1 here, so you could just leave it as the 7th root of 11 and just not put any exponent up there at all. All right, so on number 2, we've got 15 raised to the 1/3 power. So we will need a cubed root. Our root was 3, which is on the bottom. And our 15 has an exponent of 1, but again, it's not necessary that we write 1 as an exponent. Okay, number 3, we have 300 to the 3/2. So my 300 is being raised to the 3rd power, so top is our exponent, and my root is 2. So you can put a 2 here, but remember when you make a root, it's understood to be a square root if there's no number written here. So you don't have to put the 2. If it's any other number, we do have to write it. All right, number 4, we have 4 raised to the 2/3. So that would mean 4 with an exponent of 2 and a root of 3. So basically, your top always goes here, your bottom always goes here. Top goes here, bottom goes here. Top went here, bottom goes here. All right, 2 more examples. So number 5, we've got x to the 5/7. So top is my exponent, so the 5 goes here, root 7. Okay, so number 6, this one's a little tricky because the x already has an exponent of 3. But then it's being raised to the 2/7 power. So our base is the x to the 3rd. The top of my fraction is the 2, so that's the exponent. And the bottom of the fraction is 7, so that is my root. So we would write it just like this. Now, when you have a power to a power, remember our rule is to multiply. So you could multiply here. So I would have 3 times 2, which is 6. All right. In the next section, we're going to go the other direction. So here, they are all written with radicals or roots, and we want to change them into fraction form like the section above was written. So remember, if there's no exponent written, it's understood to be 1. And if there is no root written, it's understood to be 2. So I could rewrite this as 47, And remember, I always put the exponent on top and the root on the bottom. So I have 47 to the 1/2. On number 8, we also have no exponent or root written, so they're understood to be 1 and 2. So I have 7 to the 1/2. Okay, number 9. We have 10 with no exponent, so understood to be 1, but they did give us a root of 4. So I would rewrite this as 10 to the 1/4. On number 7, again, they did not give us an exponent, understood to be 1, but they did give us a root, so we have x to the 1/7. On number 11, they gave us both a root and an exponent, so I would rewrite this as 13 to the 3/4. Exponent on top, root on bottom. Number 12, x to the 2 is my exponent, so it goes on top. 5 is my root, so it goes on the bottom. All right, so notice in here we have a number and a variable. They are both being taken, having the 4th root taken. Only the p is being raised to the 5th power. If the 162 is being raised to the 5th power, it would all be in parentheses, but it's not. So the 162 does not have an exponent, so it's understood to be 1. So we would have 162 raised to the, not 1/5, to the 1/4 power, since the exponent is 1 and the root is 4. And our p would be raised to the exponent of 5, root of 4. All right, same idea on this last one. Each piece is having the 3rd root taken. However, A has a degree of 5, B has a degree of 2. Our 3 doesn't have an exponent, so it's an understood 1. So I'd have 3 to the 1/3, A to the 5/3, and B to the 2/3. And there's my answer. So we should be able to switch back and forth between radical form and fraction form, or exponential form. Okay, so now that we know what these mean, right? We know that the top number is an exponent and the bottom number is a root. We want to be able to simplify these. Now, if you were going to be using a calculator, you could just type these in with an exponent as a fraction and it would solve. However, if you are solving by hand, you have to do the bottom, which would be your root first, and then the exponent, which is your top. So if I wanted to rewrite this here, we would have the 3rd root of 27 squared. So remember, we're doing the root first, right? Bottom first. So I branch the 27. I've got 3 and 9, which splits into 3 and 3. My root here is 3, and I found 3 3s, so I get to take them out. So I have 3 squared, and 3 squared is equal to 9. All right, same idea for 216. So we would rewrite this. We're taking the cubed root of 216. It has a power of 1, so we don't have to worry about that. So I branch this. I would branch it into 6 and 36. And 36 will branch into 6 and 6. And looky there, we've got 3 6s. So we get to pull out a 6. And you could write 6 to the 1st power, but it's understood. All right, number 17. We would have the square root of 4 raised to the 3rd power. All right, so we're looking for the square root of 4. We should know the square root of 4 is 2. So we have 2 to the 3rd power, and 2 to the 3rd power gives us 8. On number 18, we're taking the 4th root of 16 to the 3rd. So we're going to do our root first. So I'd probably split this into 4 and 4, which split into 2 and 2 and 2 and 2. I need 4 of the same, and I found 4 of the same. So I'm going to get to pull out a 2, and it's raised to the 3rd power, and 2 to the 3rd power gives us 8. All right, number 19, we have 8 to the 2/3 power. So then we could rewrite this as the cubed root of 8 squared. We do the root first, so I'm looking for 3 of the same number. So I could split this into 4 and 2, and that 4 would split into 2 and 2, and there we go, 3 of the same number. So I get to pull out a 2. We've got 2 squared. Now I can do my exponent. 2 squared should give us 4. On 32, we've got the 5th root of 32 to the 3rd power. So this time we're going to have to find 5 of the same number. So I split this into 8 and 4. I can split 8 into 2 and 4. I can split 4 into 2 and 2, and this 4 into 2 and 2, and I've got 1, 2, 3, 4, 5 of the same number. So I've got, oops, not 5, 2 5s, 5 2s. So I get to pull out that 2, and my 2 is being raised to the 3rd power. 2 to the 3rd power is 8. All right, number 21, I've got the square root of 125, the cubed root of 125 raised to the 2nd power. So looking for 3 of the same number. I could split this into 5 and 25, and I can split 25 into 5 and 5, 1, 2, 3 5s. So I get to pull out a 5, and it is squared. 5 squared is going to give us 25. All right, for 81, I would rewrite this as the 4th root of 81 to the 1st power. I don't have to write the 1st power. This means I need to find 4 of the same number. So I could split 81 into 9 and 9, which will both split into 3 and 3. So then I have 4 3s. And I don't have to write the 1st power, so there's my answer. Oh, not 4 3. Goodness gracious. I have 4 3s, so my answer would be 3. Okay, number 23. So we have 16 over 25 being raised to the 1/2 power. This means that I have to raise both the top and the bottom to the 1/2 power. So I would have 16, or the square root of 16 to the 1st power, over the square root of 25 to the 1st power. And we should know that the square root of 16 is 4, and the square root of 25 is 5. And there's my final answer. I do not have to put the 1st powers. Okay, and on number 24, we have negative 216 raised to the 2/3 power. So I'm taking the cubed root of 216 squared. Oh, negative 216. So I'm trying to come up with something that would give me negatives. So I need something that would multiply to give me negative 216. So let's say that I choose negative 6 and negative 36. I mean, negative 6 and positive 36, sorry. All right. And then for positive 36, we might choose negative 6 and negative 6. A negative times a negative times a negative would give me a negative under here, so that would work. So I'm going to get to pull out a negative 6, but it is being squared. And remember, when you're squaring something, that means multiplying it times itself. A negative times a negative is a positive 36. If you're going to put this in your calculator to see what negative 6 squared gives you, make sure that you type it in parentheses. Okay, in this next section, we are just reviewing how to add fractions. Now remember, when you are adding or subtracting fractions, we need common denominators. All right, so common denominators just means that the bottom of our fractions have to have the same numbers. So here, one has a 2, one has a 4. Those are not the same. It's always easier to make the smaller one match the bigger one. So what could you multiply 2 by to become 4? So 2, so I'm going to multiply it by 2, but rules say if I do something to the bottom of a fraction, I also have to do it to the top. So I would multiply my numbers in the top. 2 times 1 would give me 2. And 2 times 2 in the bottom would give me 4. So now I have 2 fourths plus 3 fourths. And we just add the tops of our fractions. So 2 plus 3 would give me 5 fourths. All right. Here the bottoms of my fractions are 3 and 5. So 5 is the bigger number, but there's nothing I can multiply 3 by to give me 5. So I want to think of something that I could turn these numbers into, something that they're both common factors of. So the smallest thing I can probably think of is 15. To turn 3 into 15, I would need to multiply it by 5. But if I do that to the bottom, I gotta do it to the top. And over here, if I want 5 to become 15, I'm going to need to multiply by 3. Also have to do it to the top. So on the top, I have 5 times 2, which is 10, over 5 times 3, which is 15, plus 1 times 3, which is 3, over 5 times 3, which is 15. And now we have a common denominator, and we just add the tops. 10 plus 3 gives us 13, so we end up with 13 over 15. All right, last practice, we have a 6 and a 3. 6 is the bigger number. I can turn 3 into 6 by multiplying by 2. But if I do it to the bottom, got to do it to the top. So I have 1 6 plus 2 times 2 is 4. 3 times 2 is 6. So I just would add the tops of my fractions, and I would have 1 plus 4, which is 5 over 6. All right, so we need to keep that in mind. If we're going to add fractions, we have to have common denominators. Which brings us into our last section. And in our first row, we are multiplying two variables with exponents. Remember, our rule for multiplying bases is that we will add their exponents. So here, when multiplying, we add exponents. Okay, so on number 25, I'm going to need to add these two fractions, 1/5 and 3/5, because we are multiplying. So 1/5 plus 3/5. Lucky for us, this already has a common denominator, so we just need to add the tops. So I would end up with 4 in the top over 5. So when I multiplied my bases and added my exponents, I ended up with x to the 4/5. All right, on number 26, again, we are adding our fractions. So I have 2/9 plus 7/9. Again, we have common denominators, so we just add the tops. 2 plus 7 will give us 9. So we have 9 over 9. This will actually simplify. 9 divided by 9 is just 1. So I end up with x to the first, but again, we don't have to write that exponent of 1, so my answer would just be x. Okay, number 27. The fractions I need to add are 1/2 plus 2/3. So our denominators are not common here, so I'm going to need to come up with something so that I can make them the same. So there's nothing I can multiply 2 by to become 3, but I can multiply them both by something to become common. So I could multiply 2 by 3 to become 6, and 3 by 2 to become 6. And rules say whatever you do to the bottom, you got to do to the top. So I'd end up with 3 over 6 plus 4 over 6. And now that we have that common denominator, we can add them. So I would add 3 plus 4 would give me 7/6. So when multiplying m to the 1/2 times m to the 2/3, we would end up with m to the 7/6. Okay, number 28. Our fractions are 2/3 and 3/5. Nothing we can multiply 3 by to become 5, but just like on this example, we can turn them both into 15. So I multiply this one by 5 and this one by 3. So in the top, I have 5 times 2, which is 10 over 15, and 3 times 3, which is 9 over 15. We add that together, and we end up with 19 over 15. So my final answer would be A to the 19 over 15. All right, last set of examples. These ones are a little bit different because in these we are dividing. So our rule for multiplying is to add the exponents. Remember our rule for dividing. So when dividing, we subtract exponents. So in this section, we'll need to subtract our fractions. So that common denominator rule will still apply. So on number 29, the fractions we will be subtracting are 2/3 minus 1/3. So lucky for us, there's already a common denominator. So we go ahead and subtract the top. 2 minus 1 is 1. So 1/3. So our answer would be x to the 1/3. Okay. On number 30, the exponent in the bottom is not written, so it's an understood 1. So we are supposed to be subtracting 2/3 minus 1. Now this is not a fraction, but we could rewrite it as 1 over 1. And we need that common denominator. So I could turn 1 into 3 by multiplying by 3. If I do it to the bottom, got to do it to the top. So I would have 2/3 minus 1 times 3 is 3 over 3. Okay, and now we subtract 2 minus 3 is negative 1/3. So our answer would be y to the negative 1/3 power. Number 31, I have a to the 2/3 power over a to the 3/4 power. So we are subtracting here. We're going to need a common denominator first. So something that both of these would go into would be 12. I could multiply this side by 4, but then I would have to do it to the top as well. This side by 3. So in the top I have 4 times 2, which is 8, over 12, minus 9 over 12. Now I can subtract. 8 minus 9 is negative 1 over 12. So my final answer would be a to the negative 1/12. All right. So in the bottom, we have 2 fractions that are being multiplied. So I'll need to add these and subtract from the top. So first I'm going to add my fractions in the bottom. So in order to do that, I'm going to need to change this 2 into an 8. So I would end up with 1/8 plus 4/8, which is going to give me a total of 5/8. So all of this in the bottom became a to the 5/8. So now in the top, my fraction is 1/4 minus my fraction in the bottom, which is 5/8. So common denominator, I'm going to need to change that 4 into an 8. So I multiply the top and bottom by 2, and I end up with 2/8 minus 5/8. And 2 minus 5 gives me negative 3/8. So my final answer is a to the negative 3/8. So make sure you have a common denominator before you add or subtract. When we multiply, we add our exponents. When we divide, we subtract our exponents.